Okay, we'll look at a couple more of these together. Number 3, it's saying somebody's loading 50-pound boxes on an elevator and then riding the elevator. And basically this is the boxes and this is the weight. So this is going to be box on this axis. Let me pick a darker color. This is your boxes and this is your weight. Now, the number of boxes starts, as soon as you put a box on, it starts at 50. So that lets me know that L can't be it because it's got my axis backwards. My weight should start at 50. Now, when I'm choosing between A and S, it both looks like that they kind of start up at something that could be 50. We don't have numbers, so you just kind of have to guesstimate. Basically, the difference is S is connected line, A is little dots. Actually, in this case, since the weight only changes when you add another box, the dots make sense. This would be something changing gradually, like the temperature of water as you boil it would gradually increase. So that would be more like S. But this would be your boxes. So the number 3 answer should be A, because every time you add a box, it kind of jumps up, and that's why you have the separate dots. The fancy word for that is it's a discrete problem. We're going to look at number 8. He's dropping, we'll look at 7. He's throwing a rock as far as he can off the cliff. So X is time and H is height. It might be wise for us to label again. So this is time, this is height, time and height, time and height. Well, the height of the rock, this would be, it starts up high on a cliff and it gradually drops. I can see why you might think that would be it. But this is something that's more just gradually dropping due to gravity. This one here would be, it starts here and then it goes up a little bit and then down. If you think about it, if you throw something, it doesn't go straight out. If you throw it, it kind of goes up in the air, especially if you're trying to make it go a distance. So the height would actually increase for a little bit because he throws it up into the air, and then it would start to decrease and then go down below his original height and off the cliff. So the best answer for this would be T. Like I said, this one actually, you're just kind of going, the height doesn't change and then all of a sudden it's 0. That's not really what happens, even if you were to drop it off a cliff. So keep that in mind as you try this other ones. The last one I'm going to look at is situation 2. It's about an ant crawling around on the counter. So we kind of have to make our own graph on this one. So you can see if the ant starts, it's right at A. So it starts here at point A. Actually, it starts a little bit away from point, it starts right at point A. So the distance is basically 0. And then you can see the distance is moving away from A. So the distance from A is increasing. And it keeps increasing as it goes all the way around there. Then what happens is in our next part of the graph, do it in a different color, it actually, the distance stays about, the distance keeps increasing a little bit. It keeps getting a little bit further away from A, but not much. And then eventually you get to the point that it actually starts getting closer to A because it's turned around and it's coming back toward A. So we'll go ahead and do this part of the graph in yet another color. So as it starts getting closer to A, that means the distance will be going down. And then on the end, you would, as it completes its circle, it starts going away from A again. So this last piece of the graph would be, the distance would be increasing slowly and then go back into a pretty steady rate of increase. So you can see the rate of increase at the beginning of the graph and the end of the graph are the same because at the beginning and the end, it's pretty much going in a straight line, but it has this little curvy thing where the distance, where it basically keeps going away but slows down, then actually starts going closer to A on the green piece, then starts going away again and speeding back up the distance it's going away right at the beginning there, and then that straight line there at the end would be it's going back at a steady rate. Hopefully this helps you on this one, and we'll try 1 or 2 from the other worksheet if we have time. So these involve acceleration. So basically what you're going to see is if the graph is getting steeper, it's speeding up. So on this one for graph D, it's getting steeper, that's acceleration. If it's slowing down, if it's getting less steep, that's deceleration. And then if it's a constant speed, a straight line, that's like that. So that gives you the idea. That one is pretty much straight out of your notes.